In the previous class, we already discussed about the few basic terms of the thermodynamics, which are very important. I think all of you read carefully all the terms which are used in the thermodynamics, because without these terms, it is not possible to discuss the first law of thermodynamics. Myself, Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, welcome you all in my second lecture of thermodynamics. Today we will discuss about, at first, there are two, what I told you in the previous class also, that what is the reversible and the irreversible process. What is the reversible and the irreversible process? Okay, irreversible process. These are the very important. Okay, what is the reversible process and what is the irreversible process? Okay, then the most important term we will discuss today, this is the first law of thermodynamics. Okay, this is very important. First law of thermodynamics. This is very important. You have to properly have to understand this first law. Then obviously it's there must be some kinds of its expression. Okay, I will show you what is the expression of the first law of thermodynamics, and then we have to discuss the two terms are very important. One is the E. Okay, E or U, this is taken as the either internal energy, or the internal energy is represented by either E or U. And another very important term, this is the H. Okay, H is the enthalpy or heat content. Okay, so I will show you that what will be the expression of the internal energy. So without further delay, let's start the class. Students, in the previous class, we, just for recapitulation purpose, then we'll move to the our today's topic. We discussed about the very basic things, like starting from system, surrounding, boundary, isolated system, closed system. Then we discussed about the open system. Then we discussed about the heterogeneous system and the homogeneous system. Okay, then we discussed about there are some kinds of properties. There are two types of properties, like intensive property and extensive property. So which conditions are included to be intensive property, and which conditions are included for extensive property. We discussed all these things. Okay, then we discussed about the state of the system or state variables. We also discussed the thermodynamic equilibrium. There are some kinds of equilibriums are there, like chemical equilibrium, mechanical equilibrium, like thermodynamic equilibrium. That all the things we discussed in the previous class. Then we discussed about the process. Okay, there are different kinds of process. That means we can keep one parameter constant and we can continue the process. So there are different kinds of process are there. So they are like isothermal process, like adiabatic process, like isobaric process, like isochoric process, like cyclic process. That all the things we discussed. But the most two important process we did not discuss in the previous class. So we will start from these two topics. These two topics. So first one is the reversible process. Okay, so what is the reversible process, you have to know at first. So reversible, and another one is the irreversible process. So if we consider the reversible process, then reversible process generally what happen, this is very slow process. That means here generally this process, what is the reversible process? So reversible process is a process which occurs infinitesimally slower. That means that there is a very slow process. Okay, because when we are doing the process, there are like two types of forces are acting. Okay, there are opposing force and the driving force. Driving force means what we want to do, we have to apply the force, and if that particular substance, if this substance also there's some kinds of stiffness, that it will not be changed. Okay, it have no tendency to change, so it try to oppose this kind of change. Okay, so there are two kinds of forces are there. First one is the opposing force, and second one is the driving force. Okay, so when the difference between opposing force and the driving force, this is very smaller, then it is called the reversible process. Okay, so reversible process, then when the process is going to very small steps there. Okay, this will call the reversible process. Okay, then another is the irreversible process, just opposite that of reversible process. That means when the process occur from the initial to final stage in a single step, there will be no multiple step. Okay, initial to final, there are rapid process, very first process. So very firstly it move from initial to final stage, then this process will be called the irreversible process. And here the difference between the driving force and the opposing force will be very high. That means the driving force is very higher with respect to the opposing force, and that's why the process move very faster. Okay, and here it cannot be reversed because the difference is very high, so it cannot be reversed. Okay, so I can show you that how we can explain the reversible and irreversible process. Okay, so if we think about the reversible process, then if we take, this is the any container. Okay, this is any container, just think about this is any container. Okay, then in this container there is a certain amount of gas present. Okay, any gas present here. So for example, we are taking any gas here, so any gas is present here. Okay, this is the any gas present here. Now what happened in this container, then look what happened. Then if there is any piston, okay, there is any piston which is kept in on the gas on this container. Okay, this is the piston. Okay, so what happened, if you want to apply a force, okay, to decrease the volume of the gas, that means if you apply some kind of force from the upper side, okay, from the upper side, then what happen, then piston will decrease the volume, there will be pressure on the gas. Then there are two kinds of things that occur. Okay, so there will be, this is the opposing force, you are applying the you are applying the force on the piston from upper to lower side, and obviously there will be another pressure which is exerted by the gas. Okay, because gas, when you want to apply some force, gas also it apply due to its position, there will be some kinds of internal energy also there, so it also apply the force in opposite direction. Okay, so that means what happen, if it is the 1 and it is the 2, then what happen, if 1 and 2, then if 1 very greater than 2, then what happen, you can easily you can apply the force, and the gas, the volume of the gas will be decreased. Okay, so if it is very difference is very high, at a glance you can do it, or at a moment you can do it. Okay, so this is called actually irreversible process. This is called the irreversible process. But what happen if there this 1 and 2, this difference is not very high? That means 1 is obviously greater than 2, but not very high, not very high. Okay, not very high. Then what happen, then the process will be very much slower. That means piston will come here at first piston, this piston will come here. Okay, from here to it will come here, then again come here. Okay, come here first, then here. So in this way, that means there is step-by-step process, because if the driving force and opposing force, it is not very the difference, if the difference is not very high, then what happen, it will move to the step-by-step. Okay, so when the difference between the driving force and opposing force is very lower, then obviously it will be called the reversible process. But I can give you one information, that what I am telling, this is not applicable practically, because all the natural processes are irreversible. This is not like that. And what I told you, that in the example of the piston, this is only for to discuss with you, for clarification of the concept, but it is not actually, because the difference between opposing and driving force will be so small theoretically for the reversible process. We can't do in this way, that if we move the piston in slightly one by one, then it will not be just this kind of reversible process, because reversible process totally it is the theoretical concept, okay, because all the natural occurring process will be the irreversible process. The example in this way you can keep in mind, this is not the real example. I can give you the tricks by which you can keep in mind that the difference between reversible and irreversible process. Suppose you want to go to the first floor or second floor. If you are using the lift, it looks like the irreversible process. At that moment you can reach to the first floor or second floor. And if you are going through the stairs, then think that it looks like the reversible process. But this is not the real example. I am giving you the example to keep in mind, okay. This is for the tricks purpose, okay, other than this, okay, because I told you again, reversible process is the theoretical concept, and because all the naturally occurring processes are the irreversible process. So keep in mind, okay. But maximum work, when I will show you the calculation, then maximum work you can get from the reversible process, not from the irreversible process. Then come to the most important part of the thermodynamics, that internal energy. This is very important, okay. Internal energy you have to keep in mind, because this internal energy we will use in each and every time when we are doing a numerical problem or some kind of explanation. This internal energy become very important. So first of all, what is the internal energy? Internal energy is the every system having some quantity of matter is associated with a definite amount of energy. This energy is known as the internal energy, okay. For example, every system, this is the, like there is some kinds of transitional energy, some kinds of rotational energy, some kinds of vibrational energy, some kinds of bonding, electronic, etc. There are so many types of energy present for a particular case, okay. So this is called the internal energy. The summation of all the energy is called the internal energy. So what generally we can tell you that what energy present in a particular compound, this is called its internal energy, okay. So this is the internal energy. Now what are the characteristics of the internal energy? If you think about the characteristics of the internal energy, then first of all, internal energy of a system is an extensive property. I already discussed with you in the previous class that what is the extensive property, which is independent on the amount. So this is called the internal energy. So internal energy, obviously it is the extensive property. Internal energy state property, okay. This is the state function, like it depends on the initial, when there is some change of the internal energy occur, then internal energy depends on initial and final state. What I told you in the previous class, that what is the state function and what is the path function, then from there I think it is very much easier to understand that internal energy will not depend on the pathway, it only depend on the initial and the final stage, okay. Then next thing is that that the change in the internal energy does not depend on the path. What I told you, that is it is actually the case of the state function, what I already discussed with you, that there is no change of internal energy in a cyclic process, okay. Because cyclic process also I think you know, because I discussed in the previous class. Cyclic process means the initial there will be lots of change occur, but ultimately it comes to the initial stage. So now just think about initial stage. What is the meaning of initial stage? Initial stage means its initial energy. If the energy of the initial stage is the E, then after lots of change occur, finally it reach to the same energy, that is the E. So that this is the actually initial stage, meaning of the initial stage. Now if it come to the initial stage, then obviously its ultimate change will be zero, because whatever internal energy will be increasing, decreasing occur, in cyclic way it again comes to the its initial stage. So obviously there will be a chance of, there will be a case that in the cyclic process change of internal energy will be, obviously it will be zero, okay. So next come to the fact that internal energy of the system depends on the system depends upon the quantity of the substance, its chemical nature, and temperature, pressure, volume. Okay, that's why it is the extensive property. Extensive property means here that it depends on the quantity, obviously. So what I told you in the previous case, that it is the internal energy is the extensive property. Okay, so internal energy is the extensive property. Extensive property means it depends on its quantity. Okay, extensive property define these things, that it depends on the it depends on the its quantity. Okay, so internal energy obviously depends on the extensive property. If it is the intensive property, then it will be independent on the quantity. So you have to keep in mind these characteristics. Okay, so now come to the next topic, that the change in internal energy. Change in internal energy means here, look here, that it is neither possible nor necessary to calculate the absolute value of the internal energy of the system. Okay, so actually what we need, we have to calculate the change of the internal energy. Okay, that what is the internal energy of the initial stage, what is the internal energy of the final stage, that value is required for us. Okay, so now come to the most important point, heat and work, because this concept is very much important for the first law purpose, heat and work. So if you think about the heat and work, then you have to know that in case of heat can be converted to the work, or like that, the energy of a system may increase or decrease in several ways, but two common ways is the heat and work. Okay, so two common ways are the change of the heat and the work. Heat is a form of energy. It flows from one system to another because the difference in temperature between them. Heat flows from the higher temperature to lower temperature, therefore it regards the energy on the move. Okay, so heat obviously it will change from higher to lower. Okay, you know. Okay, so come to the most important part of the thermodynamics, and this is the first law of the thermodynamics. Okay, so what is the first law of thermodynamics? Okay, so generally you have to keep in mind, according to the first law, that the most common way by which we can define that energy can neither be created nor be destroyed, although it can be converted from one form to another form. You know, there's a different way by which we can define the first law of thermodynamics. There is a different way, but the most common way by which we can define the first law of thermodynamics, this is the energy neither be created nor be destroyed, but it can be converted from one form to another form. This is the most important way by which we can define the first law of thermodynamics. So look here, E2 minus E1. So what is the E2 minus E1? If you think about E2 means it is the suppose it is the change occur after subchanging, it is the E2, and E1 is the final stage. You can take it. E1 is the energy of the initial stage, and E2 is the energy of the final stage. So obviously, according to the first law of thermodynamics, E2 minus E1 equal to delta E, it is a change delta E equals to Q plus W. You can take it in this way, that for example, there is a system, this have the energy E1. Okay, very simple. It must have some kinds of internal energy. So if it has the internal energy like E1, then E1 plus Q. Okay, so E1 plus Q, that means there's some kinds of heat absorption occur. So that equals to, obviously, that if the energy will be done, work will be done, E2 energy and W work will be done. So E1 equals to E2 plus W. Okay, so this is the simple thing. E1 is the energy, Q absorption of the heat, then work done, W work done, and E2 will be the final stage. So it will be E2 minus E1, then it will be E2 minus E1, then it will be Q minus W. This is the normal case. Okay, then I can show you that how you can get this kind of mathematical formula, the concept. What is the concept? Suppose this is the system, this is any system. Okay, this is any system. So now what happened, you are applying Q amount of heat and W work you are getting. Okay, you are applying Q amount of heat and W work you are getting. So for this process, suppose you are applying some heat and you are getting some you are applying some heat and you are getting some work. Then For this purpose, you have to keep in mind some kinds of internal energy will be changed, isn't it? So if in the first stage there will be internal energy before application of the Q, then if there is the E2 and then finally it is the E1, then delta E. So delta E equals to, we can write down, so what amount of heat is applied, there is Q, and what amount of work done, W. So delta E equals to Q plus W, isn't it? So that's why here the first law tells us that delta E, change of the internal energy, this equal to heat added to the system and work done on the system. And this is very, very important because this is the first law of thermodynamics. So according to the first law of thermodynamics, it tells us that heat cannot be created nor be destroyed, but it can be converted from one form to another form. There are so many scientists which explain the first law of thermodynamics in different way, but ultimately what we are getting, that is the ultimate conclusion of this, all the statements are generally it cannot be created nor be destroyed, but it can be converted from one form to another form. Okay, so if a system it does work on the surrounding, its internal energy decreases. Okay, in this case we can write down delta E equals to Q minus W. That means what happened here, there is some kinds of taking the sign of the work. Okay, there are two types of sign you can take. That if a system does work on the surrounding, okay, if the system work, then we have to take the W as the negative. If we work on the system, then it is the positive. Okay, if that means if we will work on the system, then it will take the W positive. If system work on the surrounding, it is the negative. So then what happened, we have to take the Q minus W. So W, that value will be changed from what happened, from the direction. Either we are applying work is done by the system or work is done on the system, depending on these two facts. Okay, you have to keep in mind, if work is done on the system, then it is taken as the positive. If work is done by the system, it is taken as the negative. So here, look here, it is the negative, because when if a system does the work on the surrounding, then it work done by the system, then we are taking it is the negative. Okay, so change in internal energy equals to heat added to the system or work done by the system. So simply we can take in this way that if you are adding, look here, I can show you that how this expression will be established. Look here, that if you are adding some energy, then first suppose first it was the E1. Okay, so E1 was the internal energy of the system. Okay, E1, you are applying Q amount of heat there. So what you are getting, E2 change of internal energy, E2 plus W. You are getting these two. Okay, so finally what happened, if you write down E2 minus E1, this equal to Q minus W. So this is actually delta E. So we can write down, in place of E2 minus E1, we can write down delta E. So delta E equals to Q minus W. So in this way, actually we can also show that how it will be negative when work is done by the system. Now enthalpy is very, very important factor for the thermodynamics also. Okay, so enthalpy is a heat content. Okay, so it is a heat content of a system at constant pressure, keep in mind, is called the enthalpy, denoted by H. Okay, so heat content of the system at constant pressure is called the enthalpy. And from the first law of thermodynamics, you know, so Q equals to E plus EB, U or E. What is the sign of the internal energy? Either you can take it E or U. In some books also you can find out it is taken as the U. So Q equals to E plus PV. Why PV? PV equals to actually P delta V, because W equals to actually P pressure into delta V, change of volume. So what is the pressure you are applying on the system, and what is the change of volume due to applying this pressure? This is called the actually W, expression of W. So P into delta V, it is the expression of the work done. Okay, so then we can write down then delta Q equals to delta E plus P delta V. Okay, Now at constant pressure heat can be replaced at the enthalpy. Okay, so keep in mind, at constant pressure, if you take the constant pressure, so dq can be replaced by the delta H. So delta H equals to delta E plus P delta V. Keep in mind, so delta H equals to delta E plus P delta V. You have to keep in mind. So delta H, what is the delta H? Delta H is the change, it is the delta H is the heat change or heat of the reaction chemical process at constant pressure. So actually enthalpy is the heat change at constant pressure. Okay, so in case of solid and liquid participating in a reaction, delta H equals to 0. Delta H equals to 0. The difference between delta H and delta E is very much significant when gases are involved in the chemical reaction, because in case of solid and liquid, delta H will be 0, change of the enthalpy will be 0, but in case of gaseous substances, then you have to consider both these two. Okay, how I am showing you that delta H equals to, then delta H equals to delta E plus P delta V. You know this. Delta H equals to delta E plus PV equals to nRT. So P delta V equals delta nRT and P delta V equals delta nRT. So delta N equals to NP minus N, that means number of moles for product minus number of moles of the reactant, which you have to keep in mind. Okay. So if we want to define work, how we can define the work? Okay, so simply work can be defined in this way, that work is the, in thermodynamics we will define the work is the product of intensity factor into capacity factor. Okay, so intensity factor into capacity factor. Okay, so IF into CF. Okay, so what is the IF and what is the CF? Intensity factor means it is the amount of opposition. Okay, so it is the amount of opposition. And what is the capacity factor? Capacity factor means it is the extent by which we can remove the opposition. I will show you what is the capacity factor. Capacity factor is the amount by which it is the extent by which we can remove the opposition. It is the extent by which we can remove the opposition. We can remove the opposition. Okay, so now we have to understand that what is the opposition and what is the extent by which we can remove the opposition. Okay, so first of all look here, that for example, if we want to lift the a weight of m, if the weight of m against the height h, then what is the intensity factor? Intensity factor means it is the mg. So mg, intensity factor, into capacity factor is the height h. Okay, so if we want to expand, or if for the expansion of the gas, like or the compression of the gas, so final volume V and initial volume I. Okay, so it is the capacity factor. And intensity factor, suppose we are applying here the external pressure Pext. So what will be the work done? Work done will be Pext, external pressure, into delta V. Delta V means the volume change. Okay, so that means by the multiplication of the intensity factor and the capacity factor, we can express the work. Okay, so work is the product of the intensity factor into capacity factor. So this example is very important for the thermodynamics, that you have to keep in mind that W is equal to that is the P, that is the Pext. Pxt is the external pressure into delta V, volume change, either expansion or compression. Then I told you that there are two kinds of concept, that work done by the system or work done on the system. Depending on this fact, we can take the sign here. Okay, either it will be positive sign or a negative sign. I already I will discuss also this fact when we will discuss the things. Okay, so generally W is the Pext into delta V. Okay, so now if we'll take here, if work done by the system, then it will be taken as the negative sign, and if work done on the system, it will be taken as the positive sign. So okay, so according to this fact, we will continue the next topic. So from the first law, that we can write down that dq equals to that dq equals to, we can write down dq equals to whatever it will be the d. Okay, so according to the first law, we can write down d is the change of internal energy, de equals to dq minus dw. We already explained this fact, okay, in the first law. So then we can write down dq minus dw equals to what I already discussed, that p delta v. Okay, now if you add the term pv for the both side, okay, so here we can write down in the left hand side, it will be delta e plus d of pv, that equals to dq minus p delta v plus d of pv. We can write down this fact. Okay, so here we can write down, this is the common term, d of e plus pv, equals to dq plus v dp. Why vdp? Because after derivation here, that from here there are two terms will come. One will be pdv plus vdp. Okay, pdv plus vdp. So pdv it will be cancel out, so remaining part will be vdp, so that's here vdp. So e plus pv, that equals to, we can write down d of h equals to dq plus vdp. So finally what we get, that h equals to u plus pv. So this you have to keep in mind, that h equals to u plus pv. You have to keep in mind this fact. Okay, so h, what is the h? H is the enthalpy. Okay, so h is the enthalpy. So now there are so many terms we have to keep in mind. Okay, so first of all, look here, that these things you have to keep in mind, that that h equals to u plus pv. Okay, it is the first things which you have to keep in mind for the numerical problem purpose, for the calculation purpose. And then you have to keep in mind that delta h equals to, we can write down dq plus vdp, and I told you this is the constant pressure. So if it is constant pressure, dp will be 0. At constant pressure it will be 0. So d of h equals to, we can write down delta qp. You have to keep in mind, this is very, very important, because we will use this when we will discuss about the CPCV. Okay, what is the CPCV? I will discuss in the next class, but there it is very, very important equation which you have to keep in mind. Okay, so that's all for today. So what we discussed today, we discussed at first the reversible process, irreversible process, then we discussed about the first law of thermodynamics, it's a mathematical expression, then we discussed about the enthalpy and how we can get the expression of the enthalpy. And okay, so in the next class we'll discuss about the work done on reversible process and irreversible process, and then related to, there are some things which we have to discuss. Okay, so that's all for today. I will meet with you in the next class with these topics. Thank you, goodbye, take care.